So here we have the start of Chapter 1 in the Grade 10 GMF, Geometry, Measurement, and Finance course. The blank pages that are as they are now, before I've written on them, should be up on the website as notes, so you can have those to print off and you can fill them in as you like. And we'll just kind of go through. The definitions are up there. I'm not going to read through them. We're looking at proportional reasoning in this section, so we're going to be doing lots of proportions. At first, we're just doing straight ahead proportions, and we'll look at things like unit pricing and some more basically real life applications of proportional reasoning and ratios. Okay. So we'll get right into the examples here. The first one I have is that of mixing fuel and oil. And lots of engines require oil and fuel mixture, oil and gas mixture to run. Okay. So you have to be able to figure out how to mix them up properly. So it says that her boat here, and a two-stroke engine, has this motor boat that'll hold 25 liters of fuel. The ratio of gasoline to oil is 50 parts of gasoline to 1 part of oil. And so that's what you're given. So we'll put in 50 of gas to 1 of oil. And they could be talking any amounts of volumes, of whether it be liters, which is the case here, or gallons, or liters cubed. But in general, we'll usually be talking liters, which is what this question will have. So that's the mixture that this engine wants. It's 50 parts gas to 1 part oil. And I have a 30-liter jerry can, and I want to fill that up, and I want to be able to add the oil to it. We have to figure out how much oil do I add to that. So you say, well, I need the equivalent ratio, except for this time, instead of 50 of the gas, I have 30 of gas. I need to know how much oil goes with that. Here's where we use a little technique called cross multiplication. That's where you take the denominator of this fraction and multiply it by the numerator of this fraction, and that will equal the numerator of this fraction multiplied by the denominator of this one. So when we actually multiply that out for our question, 50 times our question mark. We can get rid of the units when we actually go through the math. When you're doing real life problems, it's in chemistry, physics, or anything like that, it's a good idea to keep the units. But in this particular case, we can drop them since I know what I'm looking for is the liters of oil. Okay? So 50 times my question mark. So 50 times my unknown is equal to 1 times 30. Easy enough, but we'll write it out. So then I have 50 times my question mark is equal to, well, 1 times 30, that's 30. And I need to have this question mark alone by itself. I don't want to know what 50 times my unknown is. I want to know what just my unknown quantity is. So I've got 50 times the question mark, the unknown. So to get rid of the 50 in front of the question mark, you do the opposite operation. So right now there's a multiplication in there, so if I divide this side by 50 and divide this side by 50, this will cross out, and I'm left with the question mark being 0.6. Now I can go back to my original thing here to see what my units are. I had 30 liters of gas up here, so I would be looking for how many liters of oil I need. So I need 0.6 liters of oil. All right, let's do another question. Example number 2, Jean-Luc, a builder, works in Kentville, Nova Scotia. He has found that he can arrange the work cubicles of his employees best if the ratio between the length and the width of the room is 3 to 2. If a room is 6 meters long, how wide should the room be? Okay. So you've got to preset ratio here of 3 to 2. That's the best ratio that he's found. Okay? So that's the length and the width. So the ratio between the length is the first number and the width is the bottom number. Okay? So again, it doesn't give units, and it's generic. It could be meters, could be feet, it could be whatever you want it to be. Okay? So 3 is the length. 2 is the width. And he says, my room that he has is 6 meters long. And so he has the length, it's 6 meters. And he wants to know, what should my width be? Okay? In this example, okay, I'm going to use a more mathematical way than the question mark. I'm going to let x represent the unknown amount. And that's more typical in math. So we'll put x in here for my unknown amount. And I know it's going to be x meters because that's the units up here. So again, we go through the same process. I have a cross multiplication. Now it doesn't matter which you do first, whether it's this and set it equal to this multiplication or the other way around. You're still going to end up isolating x in the end. It's more typical in math to have the unknown or the variable be on the left side of the equation and the answer on the right. So to make that easier and just to be to have the thing end up in the more typical mathematical fashion, I'll do this one first. So I do the 3 times the x. 3 times x, so 3 times x is equal to 2 times 6. And I'll write it out here just so that you can see what's going on, even though you can do that in your head. So I have 3 times x is equal to 2 times 6, which is 12. And again, I don't want what 3x is. I want x all by itself. Again, x is representing my unknown width up here. Okay? So this is my unknown width that I'm looking for. That's what x represents. So again, I'm going to do the opposite operation of the multiplication here. So divide by 3 on both sides. And you end up with x equals 4. And for this one, again, we should include units at the end when we write out our answer. So we'll say it's x equals 4 meters. So if you're required a sentence answer, which it would be that the width of the room that Jean-Luc should build to get an optimal 3 to 2 ratio is 4 meters. All right, we'll do one more here. It says, my grandmother can knit a pair of mittens in 3 hours. How long will it take her to knit 4 pairs of mittens? And it says, how long will it take her to knit 5 mittens? And notice here it says 5 mittens and not pairs of mittens. And so they made it a little harder. So we set up our initial ratio. It says that she can knit a pair, so a single pair, in 3 hours. And if sometimes there'll be a lot of wording to a question, and if that's the case, I find a good strategy is to underline the important information. So in this case, it's a pair of mittens in every 3 hours. Okay, so 1 pair every 3 hours. Now I want to know, how long will it take her to knit 4 pairs? So I know she's going to knit 4 pairs. And the amount of time is the unknown. So again, I do my cross multiplication. Numerator times denominator over here. Denominator times this numerator. So I have 1 times x. So 1 times x is equal to 3 times 4. So 1 times x is equal to 12. Divide both sides by 1 in order to get rid of the 1 times x. And end up with x equals, well, 12 divided by 1 is just 12. And that is hours, right? We were looking for x hours up here. So it's going to take her 12 hours to knit 4 pairs. Okay. Now, for the second part of this question, we will just do it over here. It says, how long will it take to knit 5 mittens, not 5 pairs, notice. Okay. So now I want to know about individual mittens. Well, she has 1 pair in 3 hours. That was my initial known ratio. Okay. Well, I know that there are 2 mittens in a pair, so now I can say 2 mittens is what she can do in 3 hours. Okay. So now I want to know how long will it take for her to do 5 mittens. Okay. And that's going to be in 6 hours. I want to figure that out. So once again, I'll do my cross multiplication. So 2 times x. So 2 times x is equal to 3 times 5. So I have 2 times x is equal to 15. Divide both sides by 2. You end up with x equals 15 divided by 2 is 7 1/2 or 7.5. So it's a 7.5, and it was hours for 9 units. So there's my final answer for that. So there's a few examples of ratios and proportional reasoning. The assignment will have very similar questions to that. Work through that, and the next will be section 1.2.